Today we're going to talk about APQP. A quick agenda here is a little bit about myself, objectives for the webinar. We're going to use a quick core tools overview and then talk about APQP phases, a little bit more detail, and then finishing up with the relation between APQP and PPAP. A little bit about myself, with a PhD from Purdue in Indiana, and I'm an advisor to PMC and for their quality and operational excellence. I have actually 22 plus years of experience, quality, supplier quality, warranty, program management, safe launch, focus improvement, industrial engineering, lean manufacturing, continuous improvement, facilities maintenance, pretty much every aspects of business that you can run into in a business environment. I'm a certified lead auditors with a bunch of different international standards. Not to name them all here. Some of them are the IATF 6949, ISO 14001, ISO 45001, ESD S2020, VDA 6.3, and many more others. And I do provide some, additional training on some of these international standards as they are listed all here at the bottom of this slide. We also provide Six Sigma, Black Belt, Master Black Belt, Green Belt trainings, lean manufacturing, and any, again, training from awareness level all the way to the master level training for every subject that I mentioned earlier. So that's a little bit about myself. So one more thing to add to that is I worked for Tier 1 suppliers and also the OEMs in the past. Okay, the objectives. Again, as I said, I'm going to be talking about what APQP is about and APQP in phases, and then the connection between APQP and PPAP. And as you can see at the bottom of the slide here, I have listed the core tools. We call them core tools in the automotive world, and they are advanced product planning, quality planning and control plan, APQP, production part approval process, PPAP, failure mode and effects analysis, the FMEA. There are two types, the design and process or potential. Statistical process control, SPC, and the measurement system analysis, MSA. But today, our focus is going to be on APQP. Some overview here with quality core tools. These are also known as the quality core tools. The automotive quality core tools, also known as quality core tools, or just simply core tools, are key pillars of an effective quality management system. Over 30 years ago, AIAG, the Automotive Industry Action Group, and ASQ, American Society of Quality, collaborated with the domestic automotive manufacturers, Ford, GM, and Chrysler back then, now to establish collective quality methods and tools, which became, again, as known as the quality core tools. Other manufacturing sectors, including aerospace, defense, medical consumer products, transportation, and pharmaceutical, adapted these tools over time. Most automotive manufacturers and suppliers require use of one or more of the core tools. Therefore, organizations whose employees have mastered the core tool processes can assure their customers that the industry's most qualified individuals are working on their behalf, and that IATF 6949 and applicable quality reference manual requirements will be met without fail. As I said before, you see the blue font, APQP, that's the one that we're going to be talking about today. So advanced product quality planning and control plans decrease the complexity of product quality planning for customers and the suppliers. The PPAP, the production part approval process, ensures engineering design and customer product specification requirements are met. FMEA, failure mode and effects analysis, is a risk assessment tool used to identify and address the potential failure modes in products and in processes. MSA, the measurement system analysis, warrants organization to evaluate their quality measurement systems, which in return provide better product quality. And finally, the SPC, Statistical Process Control, describes several basic and advanced statistical methods to ensure process improvements are as effective as possible. Again, we're going to focus on APQP, but for future webinars, we'll be talking about each of these core tools later on. So APQP is a structured methodology to proactively mitigate design and process risks. It ensures that the quality products can be produced by a capable production system at the intended production rates. The product quality planning requires a planning team to concentrate its efforts on problem prevention. The PPAP is an output of the APQP. So the suppliers need to use teams and checklists to accomplish each phase shown on this graph here. So after contract review, we go through the phase 1 through phase 5. And actually, I'm going to be talking about this in more detail a little bit later on. So this is pretty much capturing the product life cycle. What are some risks with product and the processes? Product does not meet customer needs. Product does not perform as designed. Product is not designed to be producible. Measurement errors lead to quality escapes. Overly restrictive tolerances lead to unnecessary rework. And excessive process variation leads to undesirable outputs. And finally, process is not capable of producing quality products at rate. So these are all potential risks with products and the processes. So where do we apply APQP? Well, we apply APQP on a new product development, existing product design revisions, work transfers, and sourcing changes, and finally, the critical items at any levels of a product structure. And one keynote here is that in general, APQP is not applied to the standard parts or the cuts. So what's unique about APQP? The greater focus is on proactive, measurable, preventive actions. Earlier engagement of cross-functional teams is required to achieve the APQP goals. And finally, increasing the rigor, the formality, and the discipline. What are some of the APQP benefits? So APQP identifies and mitigates major design and production risk early in the process so that we don't worry about those issues during production. As you can imagine, the cost of that during production would be a lot more than dealing with them upfront. Secondly, it validates a product fulfills the design requirements and the production system is capable of producing conforming product at a rate. It leverages proven industry standards for use in the development process and throughout the supply chain. And finally, documents and retains the organizational knowledge to accelerate the design and development learning curve. Okay, so the 5 phases of APQP. As you can see from this graph, there are some overlaps between the phases. So it starts with concept initiation approval, where we define the plan and define the program. Then once we define the concept and the program gets approved, then we have, so we're going to do all the planning. That's phase 1. And the phase 2 is the product design and development. The phase 3 is process design and development. Phase 4 is the product and the process validation, and phase 5 is the production. And throughout these 5 cycle, we also have a feedback, assessment, and corrective action. And I will be actually talking about each phase a little bit more detail. So if we were to focus on the planning phase, so what's going to happen here in the future slides, you're going to see I'm going to be highlighting the phase that I'm actually capturing. So this little green shadow over the faces is indicating what phase we're going to be in. So in the planning phase, and the way I'm just going to give you a little bit additional feedback on about these phases is that the methodology I'm going to be following is I'll provide the inputs, the outputs, and what are the key milestones. So it goes from left to right. Okay. So in the planning phase, what are some inputs that we can use? The voice of the customers through market research, historical warranty, and quality information, and the team experience. Business plan, marketing strategy could be used as again, one of the inputs. Product process benchmark data, product process assumptions, product reliability studies, and customer inputs. So now, providing these inputs and in the planning phase, we are expected to have design goals defined, reliability and quality goals also defined, preliminary listing of special product and the process characteristics, preliminary bill of material, the BOM, preliminary process flow chart, product assurance plan, and of course, management support. So using the inputs, now these are the outputs. So another key feedback here is that these outputs for planning phase is going to become input to the next phase. But the key milestones here we're expecting is that the product concept is finalized, a pre-design is available, and of course, all applicable activities and deliverables specified by the project plan for this phase are completed. So planning the success factors for the APQP, management commitment and the support provided from the beginning of the product development lifecycle requires function to own their respective activities and the deliverables. Multidisciplinary project teams engage and integrate all stakeholders, build unity of purpose, and foster commitment, facilitate effective collaboration and communication. Finally, the effective project planning and the management drives to timeliness based on customer needs, cascades key dates and requirements throughout the value stream, and also finally monitors execution of planned activities and removes the roadblocks. So it's really important to have the management commitment, multidisciplinary project teams, and effective project planning and the management. Okay, as for phase 2, which is the product design and development, as I said before, the output of phase 1 becomes input to this phase. So I'm not going to repeat those again, but as you can see here, all the outputs now are input to this phase. So the expected outputs for this phase are design FMEA, design failure mode and effects analysis, design for manufacturability and assembly, design verification, design reviews, prototype build with control plan, engineering drawings, including math data, engineering specifications, material specs, drawing and spec changes, new equipment, tooling, and facilities requirement, special product and process characteristics, gauges and testing equipment requirements, and finally, team feasibility commitment and the management support. So based on these outputs, the key milestones, we have 3 of those: design record and the BOM, design verification and validation plans. And as usual, you're going to see this repeated across the phases, all applicable activities and the deliverables specified by the project plan for this phase. Phase 3, process design and development. Inputs, again, coming from phase 2. The outputs expected here are packaging standards and specs, product process quality system review, process flowchart, floor plan layout, characteristics matrix. If you remember, we had actually preliminary characteristics matrix, key characteristics matrix be documented in phase 1. PFMA, the process failure mode and effects analysis. Control plan, at this time in phase 3, we call it pre-launch or pre-production control plan. Process instructions, measurement system analysis plan, and preliminary process capability study plan, and finally management support. So we also expect these key milestones that are production processes defined and deployed, successful completion of the production rate readiness, and again, all applicable activities and the deliverables specified by the project plan for this phase are completed. Phase 4, product and the process validation. Now, it's in this phase, what we do is we design and we developed a product and the process. Now we're going to be actually validating that the product and the process are working together. So for that, using the output from phase 3, now the expected outputs in this phase are significant production run. So we're going to have to run the production to validate our product and the process. When we say significant, you may actually end up having different number of parts that you have to run to validate your product and the process, and it may be customer driven. Even though 300 in a mass production environment seems to be very reasonable, and it's suggested, but again, your customer will define how many you need to run to meet their production run requirement. The measurement systems evaluation. In phase 3, we actually planned for the MSA. Here, we're actually executing that plan and evaluating to making sure these measurement systems are acceptable. Preliminary process capability study. Again, we planned for it in phase 3. Here, we're actually executing that plan again to conduct the study and making sure that our processes are capable. Production part approval. Production validating testing, packaging evaluation, production control plan. Now, again, here, a key point here in phase 3, we had a pre-production or a pre-launch control plan. In phase 4, we call it production control plan. Even though we are validating the product in the process, but the control plan in this phase is going to be representing how it's going to be in production. So that's why we call it production control plan. And the quality planning sign-off and management support. So with that, the key milestones, validation that the intended manufacturing process and the associated product conform to specified requirements, approved first article inspection, approved PPAP. The one thing I want to point out here, the first article inspection, that's a requirement in the aerospace industry. In the AS 9145 standard, requires them to actually complete this report. But at the end of the day, in the automotive world, what we're looking for is an approved PPAP. And again, all applicable activities and the deliverables specified by the project plan for phase 4 are completed. Phase 5, which is production. The key outputs here, we're actually we're actually working to reduce the variation, improving customer satisfaction, improving the delivery and the service, and finally, effective use of lessons learned or best practices. The key milestones, we're looking at continuous improvement and feedback and project closure. Some activities that we actually use in phase 5, process monitoring, the SPC. Again, we're going to talk about SPC in one of the future webinars in more detail, but SPC is used one of the prevention control methods in control plans. So you may actually, especially for key characteristic or critical items, you may actually use SPC to monitor that key characteristics that is, that may have a significant effect on the fit, form, and function of a product. The problem solving, 8D seems to be very common across the board, and some may be using A3 and others, but this is well used across not only in automotive but also other industries. As for the continuous improvement, Six Sigma, Lean Six Sigma, Lean Manufacturing, Design for Six Sigma. Those are the again the methodologies that we use in continuous improvement during production. And the knowledge management, which is the lessons learned. So the DFMAs, the failure mode and effects analysis with either process or design, they become actually the libraries and of the lessons learned. So anytime we launch a new product, we use these documents as a baseline. So as I said before, I was going to, again, not going into too much detail. The connection between the PPAP and the APQP is that the PPAP is an output of APQP, providing the objective evidence of product conformity and the production process capability. And how do we do that? There are 18 PPAP requirements for automotive. These are actually listed as the AIAG PPAP manual. So the one with the stars at the end, they also part of AS 9145 standard. And again, it starts with design records, and these are pretty much in a sequential order. So we have design records, authorized engineering change documents, if any, customer engineering approval, DFMAs, the PFDs, process flow diagrams, PFMAs, control plans. As you can see here, we have in automotive three different types of control plans: the prototype, pre-production, and production. In aerospace, they only use pre-production and production. Measurement system analysis, dimensional results for every feature, records of material performance test results, initial process studies, qualified lab documentation, appearance approval report, sample production parts, master sample, check-in aids, customer specific requirements, and part submission warrant. This one is actually in the AS 9145. It's called PPAP approval form. So if this form is signed by the supplier and the customer, that allows the supplier to ship parts to the customer. So again, without going into in more detail than what I did here, this is pretty much the summary of what PPAP is about. And we also have different levels of submission levels of PPAP that, again, I will capture that in our future webinar.